Hi, this is Paul Wolf. I'm a teacher at Hostel Academy in Springdale. I teach physics, engineering, and computer science. This summer, I was placed at Glad Manufacturing in Rogers. I had a really enlightening experience, and that helped me have a really great semester with my engineering students. Glad's one of the biggest manufacturing endeavors in the state. I wouldn't even really be able to get into all the specifics. They make our trash bags, cling and seal, press and seal, things like that. And thanks to our hosts, anybody that took time out of their day to help us and answer any of our questions was greatly appreciated. Um, Coming away from my experience there, I wanted to make sure that I had, at least in my engineering class, we were able to make some projects where they were required to use scientific understanding and reasoning. That is math and physics principles, but also how to think like a scientist. That was something that they harped on a lot in our meetings about that being how that's important in engineering and manufacturing. I wanted my students to be able to move through multiple roles throughout their project. I wanted to make sure the problem was complex so that it could be broken down into smaller, more digestible problems. And also wanted to make sure that my students stayed in communication with each other and with myself. I chose to have my students go through designing and building file folder bridges where students first build a truss bridge based on some instructions without really having a lot of prior knowledge. In the second chapter, the students learn about forces and how to measure the strength of an individual truss member. Those are the beams and the bars actually in the truss. In Unit 3, they learn the method of joints so that they can analyze the forces on their truss bridge that they had previously built in Unit 1. Um, in Unit 4, they use Bridge Designer software, first off to shorten the method of joints for them, but also to optimize the bridge's design. That one is a really deep investigation that they can learn a great deal from, especially in terms of thinking about the labor costs for the materials, not just cheaper materials, but less work to use in order to build it or to implement it. Um, in chapter 5, they use that same software to design their own bridge. They scale that design down and then build it themselves in the classroom. My lesson I put between learning activities 4 and 5. So before they built their final bridge, they went back and redesigned or made some possible redesigns to the tubes that make up the bridge itself. Um, in the original bridge, everything is rectangular. So I challenged them to try to make some I-beams, some hexagonal shapes, things like that. Test their strengths as they built them, and then propose some redesigns and some methods for testing those redesigns. This worked as a really good bridge for the last chapter because the last chapter is based on their design. So they need to have some confidence in communicating um, with each other and just the basics of like drawing and things like that. Throughout, I also referred back to this learning cycle, which also in the learning activities, I took physics lessons from this textbook, College Physics Explore and Apply by Eugenia Kina. This reasoning cycle is similar to what most teachers use. I made sure to post it in the classroom and refer to it and make sure that we all often talked about where we were in the reasoning cycle. As to me, engineering is really an application of science. In my particular learning activity and throughout the semester, um, just like the visual that I had a second ago, science reasoning is really more of a cycle. So I made sure that my students were given many chances to refine their work, both on paper or rebuilding their bridges, things like that, anything that we had time to do. I wanted to make sure that they understood that going back and trying something again is a really important part of engineering and of science. And by the end, I think they were really in tune with that. They were willing to revise on their own, asking for revision notes and things like that. This is the first project that I had overall, the overall project that was successful. That wasn't just from a kit. I think those are important, and I use that as well. But it was really satisfying to have the students build a bridge really from nothing, just from the file folders and the X-Acto knives and things like that. The groups are really enthusiastic, especially by the end. I had students that didn't meet the deadline but still wanted to test their bridge. Um, and in general, like I said, the Glad manufacturing facility is so large, I couldn't even really begin to apply everything that I learned. If I were to do it again, I would definitely focus on different jobs, maybe having students have different jobs and talk about um, one week they're in one role and another week they're in another. They might compare those roles and talk about how they inform one another as well. I have a great deal of a lot of ideas for what to do next time, but this is a really great starting point. And I'm really grateful for the opportunity and the experience. So thank you.